Hello friends, this video Conic Sections Part 1 is brought to you by examfear.com. No more fear from exam. We will study conic sections. In conic sections, we will study circles, ellipses, parabola and hyperbolas. What are conic sections? Circle, ellipses, parabola and hyperbolas are known as conic sections. And why they are called conic sections? Because they can be obtained as intersection of a plane with a double napped circular cone. I'll explain what is plane and what is double napped circular cone. Just you should know that circle, ellipses, parabola and hyperbolas are called conic sections. I'll give you example of circles, ellipses, parabolas and hyperbolas in our day-to-day life. So if you see, this is a tire which is used in a car and this tire is circular. This is one usage of circle in our daily life. In fact, you see a lot of places we use circle. Tire is one of the use case. In case of ellipse, if you see, the earth rotates around the sun. Earth revolves around the sun and the path is elliptical path. This is elliptical path. If you are talking about hyperbola, if you throw a ball, if you see that this ball covers a parabolic path. This path is parabola. This path is parabola, and if you see the stopwatch, this is hyperbola. So there are various usage of circles, for example tires, ellipses, this is the elliptical path of the earth, parabola is the path, a trajectory ball follows when you throw it, and hyperbola is the stopwatch. So these are used. So if we know circular equation, for example, we know what is how to find the equation of the circles. This can be used to find speed of the car because this tire is used in the car, correct? Similarly, if we know the equation of ellipses, where the various coordinates, how can we find this point, that point, it can be used to find speed of the earth revolution. It can also be used in various planetary motion and other astronomical world. Also, when we throw a ball, this ball always follows a parabola path. So this can be used to find the velocity of ball at different point of time, or what height it will reach, which distance it will reach. So all those things we can find if we know the equation of parabola. Similarly, hyperbola. So this is sandwich and this is nothing but hyperbola. Example of hyperbola. This is our earth and this is the example of ellipse because this path is elliptical path. This is parabola and this is example of circle. Thus we see the real life example of circle, ellipse, parabolas and hyperbolas, and all these are called conic sections. Now I will actually find out why they are called conic sections. Why not ABC section, PQR section, circular sections? They are called conic section because cone is involved, right? Circular cone is involved. I'll explain you in the next slides. So you see, this is double napped circular cone. To obtain double napped circular cone, what we do is, if we take this line and one more line which is at angle alpha, and this alpha is constant. Now if we rotate this line about this axis, this guy, if you rotate this like this, what you get is this figure. If you rotate this figure where we have one line L and one line M, both are having an angle alpha between them and this alpha is constant, and if we rotate this line, we get this figure. This figure is nothing but double napped right circular cone because this is one right circular cone, this is one right circular cone, and both are together called double napped circular cone, double napped right circular cone. And there are various terms in this which you may be interested in knowing. The line L through which we rotate is called axis. This line M, which is at the angle alpha with line L, is called generator, and the upper part is called upper nap and the lower part is called lower nap, and this is the angle alpha. These are the various terms that are used in right circular cone. double nap right circular cone. Also, if you want to see a 3D view of this, this is how it looks. Just to give you a clear picture, if you see the 3D view, this is how it looks. So in this case, the axis is not visible, it is somewhere virtual, and this line is called the line M, that is the generator line, and the upper part is called upper nap, the lower nap part is called lower nap. So this is double nap right circular cone. You take a line L, you take a line M, both are having an angle alpha between them, alpha is constant. You rotate the line M with respect to line L, you get this generator, you get this double nap right circular cone. In double nap right circular cone, we have L, that is axis, the line M is called generator, the upper part is called upper nap, the lower part is called lower nap. And if you see, the V is called the vertex, this point is called the vertex, this point is vertex, this point is called the vertex. Conic sections from napped circular cone. So if you take the intersection of a plane with the cone, we get conic sections, and that's why the word conic is there. I'll show you. This is the double nap circular cone, and we have taken this plane. Let's suppose this is the plane. Plane is nothing but a xy axis straight line, xy axis plane. So this is the plane. If you cut this double nap circular cone, you will get a conic sections. For example, now if you cut this, you will get something like this. This point, this point, this point, this point. So you'll get a cone. I don't know what you'll get. Something like this you'll get. So this will also be a conic section. So conic section is a figure or any section that is derived by cutting a double nap circular cone with a plane. So you have a plane, you have a cone, you cut the cone with the plane. What you get is a conic section. Once again, you have a double nap circular cone, you cut the cone with the plane, what you get is conic sections, and depending on the angle with which you cut, you get various kind of conic sections such as circle, parabola, hyperbola, ellipse. So we'll study that, but now you should know that circle, parabola, hyperbola, etc. all are called conic sections because they are obtained using double nap right circular cone and a plane. So to get a circle from nap cone, here the beta should be 0, beta should be 90 degree. I'll explain why. This is the angle beta alpha, which is constant, we have told. Now beta is the angle which the plane makes with this axis. This is the axis. With axis, this plane is now making 90 degree angle. So if you cut this double nap right circular cone with the plane which makes a 90 degree angle with the axis, what you get is circle. If you see, there are three different views of the circle. Just to make things clear, this is a 3D view, this is a little better view, and this is a geometrical view. So what we have done, this is the right circular cone we had, and we have cut this using a plane. And this plane now, this is the infinite plane actually, so I'll make like this. This plane is 90 degree with the axis. So if you see, what figure you get is this, and this. So if you make like this, what you get is a circle in this case. This comes out to be circle. Circle is not clear, but this comes out to be circle. So if you cut the double nap cone, that is the cone, with a plane that is 90 degree to the x-axis or 90 degree to the axis, not axis, 90 degree to the axis, what you get is a circle. Here is the view. If you see, if you draw a line here, if you draw a line here, and if you draw a line here, this is 90 degree, and what you get is a circle. The 3D representation of this is this. Similarly, when you want to get ellipse, the beta angle which the plane makes with the axis should be greater than alpha but less than 90. I'll show you. Alpha is the angle which generator makes with the axis. So this is axis, and this is our generator actually. This is our generator, this is our axis. This angle is alpha. So if you take any angle beta which is greater than alpha but less than 90, what you get is ellipse. If you see, this is ellipse we got. When you cut this, this is ellipse. There is also 3D representation of that. This is ellipse. So what we have seen, we are getting different figure based on the angle which the plane makes with the axis. In first case, when the axis made 90 degree with the plane, we got circle. Now, when the angle is greater than alpha and less than 90, what we get is ellipse. In third scenario, when we get parabola, here beta is equal to alpha. So whatever angle, this angle which axis makes with the generator, this is axis, again I'll write here axis, and this is generator, GEN. This angle is alpha. Now if the same angle is made by the axis and the plane, that is alpha is equal to beta, what we get is parabola. So in case of parabola, the angle made by the axis, the angle made by the plane with the axis is equal to angle made by the axis with the generator. So here if you see, this is the representation, 3D representation, you get a parabolic shape, and also if you want to see, you can see here. All three are same. Just to give you a better visualization, I have drawn three figures. Now we'll study hyperbola. So for hyperbola, the beta angle should be greater than 0 but less than alpha. So in such case, we get hyperbola. If you see this figure, here the beta angle which the beta angle is the angle which here again the axis makes with, this is plane and this is generator. So beta angle is less than alpha. So alpha is this angle, beta is even less than alpha, but beta is greater than 0. So in this case, whatever you get is a hyperbola. Hyperbola is something like this. If you see this curve, it looks exactly like this. So we have 4 cases. First, when the angle beta is 90 degree, we get circle. You make beta lesser, that is greater than alpha and less than 90, then you get ellipse. Then again you made beta is equal to alpha, you get parabola, and then you make beta is less than alpha, you get hyperbola. So all these, if you see, sections we have got from cones, double napped cones, and that is why all these figures are called conic sections. Now let's take conic section from the napped cone. So if you see, we got 4 conic sections, 4 kind of conic sections. In first case, circle, this angle which the plane makes with x-axis was 90 degree. So I'll say beta is equal to 90 degree. In this case, beta was greater than alpha but less than 90 degree. So what you get is ellipse. In this case, beta was equal to alpha. So this line is parallel. And in this case, the beta was greater than 0 but less than alpha. So what we got is hyperbola. So what we have seen 4 different kind of conic sections: circle, ellipse, parabola, hyperbola. All we have got from this double napped cone, but the angle which the plane makes with this cone is different. In first case, the angle was 90 degree, we got circle. In second case, the angle was greater than alpha, less than 90, we got ellipse. Third case, the angle was equal to alpha, we got parabola. And fourth case, the angle was greater than 0 but less than alpha, we got hyperbola. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.